Yes, hello, hi. Welcome back. Welcome back to EDUHUNT, IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. Now we are in 7th class. 7th class chemistry mole concept we are discussing. In this particular video, I am going to explain the application of mole concept to the gaseous state. Are you getting what I am saying? You know, chemistry is the study of matter. Chemistry is the study of matter. And we need to measure the amount of substance, amount of matter. So, to measure the amount of matter, we need a unit. So, mole is a unit for amount of substance. So, okay, fine. But, how to apply that mole concept? How to apply that mole concept to the gaseous state? That means, when the matter exists as a gas, you know very well, matter exists in 3 different physical states: gaseous state, liquid state, solid state. Okay, now we are going to discuss if the matter exists in gaseous state, how to apply the mole concept to that gaseous state. Okay, yes, let's start. First of all, any gas, to study any gas, we need some gas laws. That means a gas is gaseous state is already studied by so many scientists. Okay, gaseous state is studied by scientists already, and the result of their studies is given to us in the form of laws. Okay, those are called gas laws. Okay, like there are some laws called Boyle's law, Charles' law, Avogadro's law, like that. So, simply a gaseous state should follow all those laws. Simply saying, a gaseous state, that means a gas, should follow all those laws. Okay? Now imagine there is a gas which is following all gas laws. What are the gas laws? First of all, I will tell you. There are some laws called Boyle's law. Boyle's law. Okay? Charles' law. Charles' law. Okay? Similar to Charles' law, there is another law called Gaseous law. Okay? Boyle's law, Charles' law, Avogadro's law. These are main things. Avogadro's law. So, what happened? Scientists in the beginning days or long ago, scientists have studied the gaseous state. When scientists studied that gaseous state, they understand something. No? When they studied, they understand something about the gaseous state. So their understanding is given to us in the form of gas laws. The one gas law, Boyle's law, Charles' law, Avogadro. So these gas laws we are going to study in detail in a chapter called gaseous state, or in some books it is given as states of matter. Okay, anyway, we are going to study these laws. But the point is, now you have to imagine a gas which follows all the gas laws. Imagination. But actually, in reality, the real gases, the real life gases we see in our real life is not going to follow these laws strictly. There are exceptions. But the point is, we are going to assume now. You need to assume first. Okay, to understand mole concept. First of all, assume that there is a gas which follows all the gas laws. Now, if any gas follows the gas loss under all conditions, then it can be called as, ideal gas. Okay? Ideal gas. Now if someone asks you what is ideal gas, you have to tell a gas which obeys all gas laws. A gas which obeys all gas laws is called ideal gas, but in reality all gases are real gases. See, if I ask you, give me some examples for gases, ante what examples you will give? You will say, sir, carbon dioxide, sir, oxygen, sir, nitrogen, sir, ammonia, sir, methane, sir, sulfur dioxide. Like this you will tell, na? These are the real life gases you see or you talk about in your subject. All these are real life gases called real gases. All these gas laws strictly don't follow these laws. But what we are doing, we are assuming if there is a gas which obeys all gas laws, then that imaginary gas is called ideal gas. Okay? Now what I am doing, I am going to summarize all the gas laws into one equation. We are going to summarize all the gas laws into one equation called ideal gas equation. Ideal gas equation. So previously what I told you that if a gas obeys all gas laws, then it is ideal gas. Now what I am saying, if a gas follows ideal gas equation, then it is ideal gas. Because ideal gas equation came from summarizing all these, na? Simply. So what is that equation, sir? PV is equal to nRT. PV is equal to nRT. So in this, what is P? P is equal to pressure. Pressure is measured in atmospheres, or in general we measure in bar or atmospheres. Okay? Pressure. V is equal to volume. Okay? We measure volume in liters or meter cube, ml. Okay? And N is equal to the mole concept, number of moles. Number of moles. Okay? And R is nothing but universal gas constant. It is called universal gas constant. And its value is 0.0821 when the units are liter, atmosphere, mole inverse, Kelvin inverse. These are the. See, you have to remember the value of the universal gas constant as 0.0821 liter, atmosphere, mole inverse, Kelvin inverse. See, I'll tell you how it came. See, R is equal to PV upon NT. Now you decide. If R has some value X, now what are the units? Units will be pressure unit into volume in unit divided by mole into temperature. So pressure ATM, volume liter, mole in the denominator means mole inverse, temperature unit is Kelvin, so Kelvin inverse. So and the value is practically determined 0.0821. So remember always, in the upcoming talk of concepts we are going to have some numericals. While solving that numericals, you need this value, R value, universal gas constant value 0.0821 liter atmosphere mole inverse Kelvin inverse. Yes, approximately 1 atm can be called as 1 bar approximately. So pressure can be taken in atmosphere or bar. Okay, fine. So are you getting this? And one more thing, the T is nothing but temperature in Kelvin scale. Temperature in Kelvin scale. Okay, now do remember PV is equal to nRT. How, sir? How this equation came, sir? Yes, see, Boyle's law has some equation, Charles' law has some equation, Avogadro's law has some equations. We added all this. We added all the three and we got this. Sir, how this came, sir? All these things we are going to study in states of matter. But in this video, I am going to explain the application of mole concept to the gaseous state. To do that, I need to explain this to you. Otherwise, you can't understand this topic. Okay? Now, move. I am taking next page. Now, I am taking any gas. Let us take methane gas. Assume methane as ideal gas. Okay? Assume methane as ideal gas. Okay, fine, sir. Okay. See, methane is a real gas, but we are assuming it as ideal gas. Okay, ideal gas means methane obeys PV is equal to nRT. Obeying means what? If you substitute the pressure and volume of this gas and the temperature of this gas and the number of moles of this gas, then the PV value will be exactly equal to nRT value. That is what obeying means. So PV is equal to nRT. It obeys PV is equal to nRT because I assumed it. It's assumption. Now, how much volume? We don't know. First of all, take number of moles is equal to 1 mole. Just 1 mole. I am taking 1 mole for example purpose. And what are the conditions? Let's take temperature is equal to 273.15. Approximately you can take it as 273 Kelvin. Actually in Kelvin scale I have taken 273. You know what will be in Celsius scale? In Celsius scale 0 degree Celsius. That means okay. So how to convert the temperature in Celsius scale into Kelvin scale? Temperature in Celsius scale plus 273 will give you temperature in Kelvin scale. So in 0 degrees is the Celsius scale. If the temperature is in Celsius scale 0, then you add 273, it will become 273 Kelvin. Okay, fine. And what is the pressure I am taking? For example purpose, I am taking the pressure just 1 atm, 1 atmosphere. Okay? So, pressure I have taken something, 1 atm. Number of moles I have taken 1 mole. Temperature I already taken. That means what I am doing? I am taking particular conditions. Okay. R value we already know. So, what is the unknown thing there? The unknown thing is the volume only. Volume. Okay? Now decide. I am taking particular conditions called temperature 273 Kelvin or 0 degree Celsius. Pressure 1 atmosphere, or you can take 1 bar approximately, no problem, 1 atmosphere. And R value you know. Now what is the volume? Volume. So from PV is equal to nRT. From PV is equal to nRT. V is equal to nRT by P, right? V is equal to nRT by P. Okay, sir. Okay, sir. Now what I am going to do? I am going to substitute the number of moles taken by me and R value and temperature taken by me and pressure taken by me here. I am going to substitute here to get the volume. Okay, sir. Fine. Do it. No problem. Now, what is this? Volume of 1 mole methane, right? Volume of 1 mole methane, because I have taken 1 mole, is equal to number of moles. How many moles I have taken? N. 1 mole, sir. Okay, 1 mole into, what is the R value? R value we already know, 0.0821. Previously I wrote 0.0821. And what are the units I mentioned? Liter, atmosphere, mole inverse, Kelvin inverse. Liter, ATM, mole inverse, Kelvin inverse into, and the temperature, what's the temperature? Temperature is how much? 273 Kelvin. 273 Kelvin upon pressure. So pressure, how much we have taken? 1 atmosphere. 1 atmosphere. 1 atm. Okay. So I substituted along with the units. Okay. Now cancel out the units. See what happens? Mole inverse cancel. See, let me write this properly so that you can see it properly. Atmosphere, liter, the unit of R value 0.0821 liter atmosphere, mole inverse, Kelvin inverse into 273 Kelvin. Okay, fine. Now mole inverse got cancelled. Kelvin inverse got cancelled. Atmosphere and atmosphere got cancelled. So in the entire term, the only unit left is liter. I hope you understand. So what you are calculating? You are calculating volume, so you are getting volume in liters. Okay, sir, fine, sir. So volume is equal to, I am casually writing this one value, 1 into 0.0821 into what you left there, 273 upon pressure also 1. See, casually I am writing 1, okay? Into liter. That means you are getting volume in liters. Okay, sir, fine, sir. Do calculate that one. Okay, I know it already. So 0.0821 into 273. If you multiply that, 1, okay, fine. 0.0821 into 273, you are going to get 22.4 liters. So V is equal to 22.4 liters. But let me be particular. What is this V? Sir, V volume, sir. No. Be particular. What is this V means? V is the volume. Volume of what? Volume of methane, sir. No, be particular. Volume of 1 mole methane in these conditions. Volume of 1 mole methane in these conditions. Sir, is these conditions have any specialty, sir? Yes. These particular conditions have a special name. These particular conditions called a special name. These particular conditions are called with special name called STP conditions. Standard, write down carefully. Standard temperature and pressure conditions, or simply NTP conditions also you can call. Normal temperature and pressure conditions. So for reference we are going to take some standard temperature and pressures called temperature at 273 Kelvin. When temperature is at 273 Kelvin and the pressure 1 atmosphere, these particular conditions are called standard temperature and pressure conditions, STP conditions. So, see, what is this volume? Volume of 1 mole. This is volume of volume of 1 mole methane at STP. STP conditions, right? Now let me ask you a question. Volume of 1 mole methane at STP conditions is 22.4 liter. Let me ask you a question. So this is the number of moles. This is the number of moles. This is the pressure we have taken, and this is the temperature. See, R value is anyway going to be constant now. So if you fix the temperature and pressure, you observe carefully. If you fix the temperature and pressure, that means these two are constant, and R value anyway it is already constant. Now if you keep the temperature and pressure constant, this entire term is going to be constant, na? Then the value of volume is going to be decided by only number of moles. You have taken here 1 mole, that's why 22.4 liter. Imagine if I have taken here 2 mole, then how much volume it will be? 2 into 22.4 liter. If I have taken here 3 mole, then the volume will be 3 into 22.4 liter. Are you getting? This is what actually Avogadro's law. Avogadro's law means volume is directly proportional to number of moles, because this is constant, right? So the point is, it is not about methane, it is not about any other, it is about all ideal gas. It is not, see, there is nothing particular about methane here. In this entire equation, we didn't consider anything only applicable to methane only. It is for ideal gas. So volume of 1 mole of any ideal gas, okay, volume of 1 mole of any ideal gas at STP will be this only. Volume of 1 mole of any ideal gas at STP will be this only. Okay, are you getting? So let me be very clear about this. You know very well, 1 mole of any substance, we have taken 1 mole methane, right? In the previous class of mole concept, I told you the mass of 1 mole is, what is the mass of 1 mole of any substance, whether it is gas or anything? 1 mole means how much mass? Gram molecular weight. So you have taken 1 mole methane means how much mass you have taken? You have taken 16 grams methane, no doubt about it. Do you remember? You have taken 1 mole methane means you have taken 16 grams methane. So that means the volume occupied by that 16 grams is 22.4. That's why this volume is called gram molar volume. Why sir? Volume occupied by 1 mole. 1 mole means how much mass? Gram. 1 mole means how much mass? Molar mass. Sorry, wait. So why this volume is called gram molar volume? Because this volume is the volume occupied by 1 mole of any ideal gas. 1 mole of any ideal gas at STP. So simply 1 mole of any ideal gas at STP will occupy 22.4 liters. Okay, let me take next page to explain this further to you. See, there is a reaction. For suppose there is a reaction like SO2 plus O2 gives rise to SO3, SO2 plus O2 gives rise to SO3. All are gases. Okay, sir. We know all are gases. It's a gaseous reaction, sir. No problem. And let me balance this. I can balance this like 2, 2, right? You know very well how to balance this. In the previous page, what I explained, let me summarize that. See, PV is equal to nRT. PV is equal to nRT. V is equal to nRT by V, nRT by P. Okay. You know that R is constant. R is constant. Now you take STP conditions. I am taking STP conditions means I fixed the temperature to 273 Kelvin. I fixed the pressure to 1 atm. And R value already fixed 0.0821 liter atmosphere mole inverse Kelvin inverse. It means when I fixed STP conditions, this entire thing got constant. It means how to write that? Volume is equal to some constant into number of moles. That means volume directly proportional to number of moles. This is what called Avogadro's law. This is called Avogadro's law. Sir, what is the law, sir? Yes, you can write the Avogadro's law by your own if you understand this. See, at STP, see, I will train you to remember Avogadro's law here only. See, at STP conditions, volume of a ideal gas is directly proportional to number of moles. That's it. At STP conditions, simply by looking at this. But not at STP conditions. You take any conditions. See, if I change the conditions, what will change? If I change the conditions, what will change? Temperature will have different value, pressure will have different value, R will have same value, but anyway, but relation will be same like this, na? At STP, the molar volume, the gram molar volume will be 22.4 liter. If you change the pressure to different value, change the temperature to different value, you will get the value of you will get the gram molar volume value different, but the relation will be same, na? Volume will be directly proportional to number of moles when these two are constant. Yes. Okay. Now, see, you know how to write the balanced equation. We have written the balanced equation. Now I am going to express. For suppose I have taken this one 2 mole. Suppose I am supposing if I am taking this SO2 gas 2 mole and treated with 1 mole. Okay, I am considering this. I am taking 2 mole SO2 and treated with 1 mole O2 according to the reaction, and after completion of the reaction I got 2 mole SO3. Okay, everything written here. Okay, so 2 mole SO2 on reaction with 1 mole O2, I got 2 mole SO3. This is what happened in the entire process. Now what I am going to do, I am going to express the gas. You see, the 2 mole SO2 or 1 mole O2 or 2 mole SO3, all are gases. Now I am assuming them as ideal gases. Okay, that means they are following PV is equal to nRT. When they are following PV is equal to nRT, volume is directly proportional to number of moles. Okay, now imagine I am going to express this mole relation. The mole relation, what is mole relation, sir? The moles of reactants and moles of products. There is a mole relation here. Yes. Now I am going to express this mole relation in terms of volume at STP. I am going to express, see, I am not saying that this reaction takes place at STP. This reaction might have takes place at other conditions, but the participant moles are under reactant moles and products moles are there, na? I am going to express that mole values in STP condition in volume terms. Okay, at STP. What you know? At STP, 1 mole of any gas. What you learned previously? At STP, 1 mole of any ideal gas. At STP,
occupies 22.4 liters. Remember this always. 1 mole of any ideal gas at STP will occupy 22. But volume depends upon mole only now. If the conditions are fixed, volume depends upon number of moles only. If 1 mole occupies 22.4 liter, then 2 mole occupies 2 into 22.4, 3 mole 3 into 22.4, 4 mole 4 into 22.4, like that. Yes. So imagine 1 mole O2. 1 mole O2, if you measure the 1 mole at STP, it will be 22.4. Okay? At STP. If 1 mole 22.4, then 2 mole will be 2 into 22.4. And this is also how much you are getting? 2 into 22.4. Okay? Yes. So at STP, you know that gram molar volume is 22.4. That's why you can express like this. Imagine there is some other conditions. There is some other conditions. At that other conditions, gram molar volume we don't know practically. There are some other conditions. At that, the gram molar volume is V liter. You assume like that. Gram molar volume is V liter. That means volume of 1 mole of ideal gas is V liter. Okay? Now, volume of 1 mole V liter means then 2 mole 2V, 2 mole 2V. Are you getting? See, it's not, you are not supposed to express the volume in always liter only. If the volume is given in ml also, the relation will be same, na? Huh? Yes. How? For suppose there is some other conditions, there is some X conditions. At that conditions, oxygen is taken VML. Oxygen is taken VML. If it is VML, obviously SO2 will be 2 VML. Then the SO3 formed will be 2 VML. What you understand by this relation? What you understand by this relation? The reaction, if this is a gaseous reaction, or if you are studying a gaseous reaction, in a gaseous reaction, the mole ratio in which the reaction is taking place is same as the volume ratio in which the reaction is taking place. అంటే రియాక్షన్ ఏ మోల్ రేషియోలో జరుగుతుందో అదే వాల్యూమ్ రేషియోలో కూడా జరుగుతుంది. Are you getting this? Yes. The point is, for suppose in this reaction, if oxygen is 10 ml participating, oxygen participated is 10 ml, this will be obviously 20 ml, and the SO3 formed will be 20 ml. So this kind of explanation is actually called Gaseous law. There is a fundamental laws of chemistry. This law is called Gaseous law. Gaseous law of combining volumes. So with the help of that law, we can understand how the mole concept is applicable to a gaseous state. Okay? Simply, with one more example, I will finish this. For suppose, there is N2, nitrogen reacts with hydrogen to give ammonia. This is a gaseous reaction. Okay, fine. Nitrogen gas, hydrogen gas, ammonia gas. Now let's balance this. 2 and 3. Okay, fine. Now according to the stoichiometry, there is 1 here, there is 1 here, there is 3 here, 2 here. The what stoichiometry is telling to you? If the nitrogen is 1 mole, I am saying if the nitrogen is 1 mole, hydrogen will be 3 mole. Okay, and ammonia formed will be 2 mole. Okay. Now apply this mole concept to the gaseous state. How, sir? Fix the conditions. If I measure the moles, if I have taken this amount of substance at STP conditions, okay? At STP conditions. See, I am not saying this reaction takes place at STP. This reaction can take place at any conditions. but I am measuring, I am taking this moles at STP. 1 mole of any gas, any ideal gas, if assume all are ideal, 1 mole of any ideal gas occupies 22.4 liter. Okay sir, fine. If 1 mole is 22.4, 3 mole will be 3 into 22.4. This will be 2 into 22.4. That's the point. Okay? Liters. So the point is 1 mole of the volume occupied by 1 mole of ideal gas at STP. This is called gram molar volume. Gram molar volume. Suppose if gram molar volume is V liter, if it is V liter, then this will be 3 V liter, and that will be 2 V liter. That's the point. Okay? Yes, I hope you got this. Soon we are going to solve some questions based on this particular concept in the upcoming worksheet. Okay? Thank you.